One of the things that I have to remind you of is the idea of how important factoring is and that we continue to use it. If you chose not to get really good at factoring, you're going to find this section really challenging. It's not too late. Make sure you continue to work on it. Make sure you continue to practice it. I'm going to show you another method based off of grouping that we now can do for trinomials. But again, at the end of the day, how you factor trinomials is up to you. I just want you to get it right, okay? So this section is going to be factoring polynomials like they are quadratics. And I say, remember these. Here's an example of the type of problem that I mean. This is a quadratic equation. The difference between this and one of the ones in the questions that you were just working on is that it is factorable. So I want you to factor it. Solve by factoring. We're not doing quadratic formula. We're not doing completing the square. We're not using square root property. I want you to factor what's on the left-hand side. So do that and solve it now, please. What is my first move when I factor? Greatest common factor. Is there a greatest common factor? No. So when I have a trinomial, so my first move is to take this 4 and multiply it by the 3. Now, if you use guess and check, fine. Use guess and check until you figure it out. But this will make it easier to do. Okay. What are the factors of 12 that add up to -8?
6 and 2.
Negative 6 and -2. Now, this is the start of the box method, but since I've taught you grouping now, you can also do this problem using grouping. And essentially what it is you go 4x squared and you break this middle term up. Make it -6x minus 2x plus 3 equals 0. Because that's why I find these factors, to change the middle term into that. From here I can group. Again, you don't have to do it this way, it's just another way. There's a greatest common factor here of 2x. I'm left with 2x minus 3. Inside here, leading term is negative, so I want to factor out a negative. 2x minus 3. So this is 2x minus 3 times 2x minus 1. This is just the box method, except instead of using a box. We use grouping instead. That's all the box method is a grouping method. Okay? End of the day. How you arrive at your answer is up to you. I really don't care. But you're supposed to know how to factor a trinomial at this point. We've talked about that, seems like a lot. Okay? And again, if you have not gotten good at that yet and found the method that works the best for you, you need to find it, and you need to find it quickly. Okay? So, long story short, that's one. Here's what it looks like. Okay? And then in order, it's factored, but now I need to actually solve it. So what do I do to solve it? Erica, what do I do? Separate them and set them equal to 0. Okay? So what's the solution out of this? 3 over 2. And what's going to give me 1 over 2? So those are my solutions. This method, this process, we are going to basically use with higher degrees. Okay? So your ability to factor a regular quadratic is going to be really important for the problems that you're going to be working on. But we're not actually going to have quadratics. Okay? Any questions about this before I move on? Now keep in mind this problem, 4x squared minus 8x plus 3. What we're going to be working on is the same thing with higher degree polynomials. Okay, because quadratics, what's the degree of a quadratic? 2.
The highest.
Right, which is 2. Quadratics are always degree 2. Okay, now we're going to work with ones that are higher degree, like this. So notice the numbers are the same, but the variables are different. I did that on purpose so we don't have to factor another one. For x to the 4th minus 8x squared plus 3. So how many solutions should I end up with? I should end up with 4 because the degree is 4. Okay? Now, essentially what we're doing today is you're going to have problems like this, 4th degree, and I'm going to factor it like it's a quadratic, except it's obviously not a quadratic, but we're going to treat it the same way. If you think back to that other problem, the middle term, that variable is what gets used in the two binomials, right? When I had 4x squared minus 8x, I had a 2x and a 2x. That middle term, that middle variable was what got used in the binomials. The same thing's going to be true here. Okay, so I would do this the same way. I go 4 times 3, it's 12, factors of 12, that adds to negative 8, negative 6, negative 2, and I proceed the exact same way. The only difference is, instead of factoring it 2x minus 3, 2x minus 1, it's 2x squared. And this x squared and this middle term all line up. And if you multiply these together, I get 4x to the 4th. Okay? So you can think about how to come up with these variables a couple different ways. You can pull it right from the middle term of the trinomial. It'll be that. You can take the square root of x to the 4th. It'll be that. But in either case, they're going to be the same. Okay? Now, the process, once you get it factored, the process is the same as what we did before. But because of these squareds, it becomes a little more complicated. Now, I still set this equal to 0 and this equal to 0, like that. That part's the same. And we've solved lots of equations like these, right? Whenever there's not an x term, but there's an x squared term, what property do I use? Do you remember what it's called? Square root property, very good. So, square root property means get the x squared by itself. So again, my process is the same as what I did before. I add the 3. I add divide by 2 on both sides. Okay? And so x squared now equals 3 over 2. X squared equals 1 over 2. So the difference between this problem and the problem we just did was because of that x squared. Well, how do I solve for x? Take the square root of both sides. And when I take the square root of both sides, I also have to do what? Have the plus or minus. Whenever you take the square root of both sides, you have to use the plus or minus. And that's where my 4 solutions come from. So when I do that, I get x equals plus or minus the square root of 3 over 2 and plus or minus the square root of 1 over 2. And here's when it starts to get more complicated. Okay, because this is 2 solutions, 1 plus, 1 minus. Another 2, 1 plus, 1 minus. Okay? In reality, this is the same as the square root of 3 over the square root of 2. Any issues with that? Yes? Correct. No radicals in denominators. Well, no, they were there. They were always there. Okay. So, what do I do now? How do I get rid of those radicals in the denominators? Nope. Huh? No. Well, yeah.
You multiply. Yeah. Don't you multiply both top and bottom times square root of 4?
No.
Square root of 2.
Square root of 2. We rationalize the denominator. So we've done this before too. Multiply top and bottom by the square root of 2. Because what's the square root of 2 times the square root of 2?
2.
2. The square root of 4, which is 2. So that makes the radical go away. On top, what's the square root of 3 times the square root of 2?
Square root of 6.
Square root of 6.
You have to. So it's the square root of 6 over.
So now I've rationalized the denominator. I've gotten the radicals out of the denominator. Square root of 6 on top. 2 outside of a radical. Square root of 1 times the square root of 2 is square root of 2. Okay. There are my 4 solutions. There's my final answer. So, let's talk about this problem a little bit. Initially starting off, it's just like a quadratic, even though it's not a quadratic. In the book, they even replace it. I think they say u equals x squared, and then they rewrite the problem as 4u squared minus 8u plus 3, factor it, and they get down to here, and they're like, but actually, the u equals x squared, and so then we're back to this. Okay? And then you're going to have some more of this work.